Dear students, in this chapter we are going to discuss about springs. We have a number of applications using springs in bicycles, then bike. In most of the places we are using springs. So these are the elastic bodies which absorb energy due to the resilience. The absorbed energy may be released as and when it is required, a spring which is capable of absorbing the greatest amount of energy for the given stress without getting the permanently distorted is known as the spring the best spring. The two important types of springs are leaf spring or laminated and helical spring. The classification of springs are helical spring, leaf spring, spiral, torsional, tension helical spring, and compressive helical spring. So the helical spring is made up of a wire coiled in the form of helix. It may be in circular, square, or rectangular cross section. Then it is further classified into open coil spring, compressive helical spring, closed coil springs, or tension helical springs. And helical tension springs characters. It has some means of transferring the load from the support to the body by means of some arrangements. It stretches upward to create load. The gap between the successive coil is very small. The wire is coiled in a sequence that the coil is turned in the right angle to the axis of the spring. The spring is loaded along the axis. By applying loads, the spring elongates in actions as it mainly depends upon the end hooks. Applications of garage door assemblies, vice grip pillars, and carpentries. Helical compression springs character. The gap between the successive coils larger. It made up of round wired and wrapped in cylinder shape with a constant pitch between the coils. By applying the load, the spring contracts in action. There are mainly four forms of compression springs shown in figure: plain, plane and ground, square and ground end. Applications are ballpoint pens, then pogo sticks, then valve assemblies in engines. Torsional springs. The character, it is also a form of helical spring, but it rotates about its axis to create load. It releases the load in an arc around the axis as shown in figure, mainly used for torque transmission. The end of the springs are attached to other application object so that if the object rotates around the center of the spring, it tends to push the spring to retrieve its normal position. Applications are mount racks, then tracker switches, door hinges, then clipboards, automobiles, tortoise. Then spiral springs character. It is made up of band of steel warped around itself a number of times to create the geometric shape as shown in figure. Its inner end is attached to an arbor and outer end is attached to a retaining drum. It has a few rotational and also contains a thicker band of steel. It releases the power when it is unwind. The applications are watch, automotive, seat recliners. Then leaf springs. It is a simple form of spring commonly used in the suspension vehicles. The main characteristic, the center of the arc provides the location of the vehicle axle, which is the tie holes are provided at either end for attaching to the vehicle body. Heavy vehicles, leaves are staked one upon the other to ensure rigidity and strength. It provides dampness and springing function. It can be attached directly to the frame at the both ends or attached directly to one end, usually at the front, with the other end attached through a shackle, a short swinging arm. The applications are mainly used in automobile suspension system. The advantage is that it can carry lateral loads. It provides braking torque. It takes driving torque and withstand the shocks provided by the vehicles. Okay. The nomenclature of the springs are active coils, angular relationship of ends, buckling, close ends. Okay, these are the terms used in the spring. The springs in parallel equation as K1 K2 divided by K1 plus K2. In parallel, K is equal to K1 plus K2. Laminator or leaf spring. The theta equal to 3WL divided by 2N into PT square. Okay, these are the expressions and this is the numerical problem. Thank you.